Okay, so example 5 under compound interest on other intervals, because we've just been doing where K was 1, so let's change K up. So given that we're investing 2,750 Japanese yen is invested at 4.5% nominal interest rate. Remember, nominal means we're just going to ignore inflation and deflation and all that kind of stuff. Determine the value of the investment after 4 years if it's compounded half yearly, quarterly, and monthly. So these are ones where that K value is going to be different. So let's come down here and look at this. If we do it half yearly, that means twice a year we're going to do this. So the number, which we're doing it over 4 years, right? This is what's going to change. If we're doing it 4 years, but twice every year, we have to say how many times is this going to be compounded. So 4 years times the half year. So twice in a year. This one would be over 4 years, but this time it's going to be quarterly. There's 4 quarters in a year. So we would multiply that by 4 to get the number of times it's going to do it. And this one, over the course of 4 years, if we were doing it monthly, this would be over 12 times 4 over 4 years. Okay? So it's going to be a lot bigger. The interest rate is the same on each of these. It's 4.5, 4.5, and 4.5. We're investing 2,750, so 2,750 each time. So you can see where a lot of this doesn't actually change. We're not doing a payment, so I'm just going to leave that blank. And we are trying to figure out that future value. The payments per year, well, let's see, we're doing 2, I'm going to circle this, 2 payments per year, right? Because we're doing it half yearly. For quarterly, how many payments per year will that be? That'll be 4. That's this one right here. Monthly, that's where this 12 came in, and this 12 is going to be down here. Now remember, it's going to default down here to that same number, compounded yearly. So here we go. So we're going to go to Apps, Finance. Here we go. I'm going to do 4 times, 4 years, twice each year. The interest rate is 4.5. I'm investing 2,750. I'm not making a payment, but I do want to know the future value, but I need to be sure. Okay, I have to put 0. I'm going to do this twice, right? So this is what I want to know, that future value. So alpha, enter to solve it, and I get 3,285. I'll move this over here. I'm going to put this in red. 3,285.79. Okay, now what if I take the same investment, but instead of doing it twice a year, I do it 4 times a year? So I'm going to go back up to the top, and I need to change that. Still 4 years, but now we're doing it 4 times each year. That would mean down here, we're going to do 4 payments every year. We're going to clear that out, and we need to solve for that. So alpha solve. This is, and it's not a huge difference, right? 3289.04. All right. Now, what happens if we compound this interest every single month? So we're going to go back up here. We're still doing 4 years, but now we're doing it 12 times a year. Everything's going to stay the same. I do need to change this to 12 times a year. Clear that out. Alpha solve, and there we go. $32,091.24. I don't remember if it told me, it didn't tell me what to round to, so I did money, pennies. So let me box that in. So you just have to pay attention to how often is it going to be compounded. So now let's do something different. What happens if there's depreciation? Okay, sorry, my son must have watched a funny meme. A washing machine costs 450 euros and it depreciates at a rate of 15% per year. That's actually about right. This is a little bit low, but euros are a little bit more than $1, so that might be closer to $550 or $600. Write an equation for the future value. Here's what you need to know. When you're working with depreciation, you know how we have that future value equals the present value times 1, and then we say plus, and then we say R over 100K to the K times N. When you're doing depreciation, you need to think subtraction and this would be subtraction here. Okay? Same formula for the most part. The biggest difference is that now we are subtracting. All right, so let me put that there. And I just want to remind you that you are subtracting. So let's see if we can figure this out. So we know that the present value is $450. We know that the rate is 15%. And we know that the K value is, we're just doing it once, but we don't know, write the equation after N years. We don't know the N. That's kind of what we're trying to figure out. Write an equation, the future value, yeah. So if I were to write this, and I wonder, the reason I can't really use my calculator, I don't know the future value, but I also don't know N. Right, write an equation, and this says to write an equation, so my calculator doesn't really give me an equation, but this does. So the future value would equal PV, the present value, times 1 minus, and remember we put the percent in as, we don't change it to a decimal, 100 times 1. And then we need to do to the n times k, which would be 1 times n. Let's simplify that. And you're going to see something here when we do this. Okay, I'm going to do some of this on my calculator. I'm going to do this. 1 times n, really, would you agree that this is going to be 450? I'm going to have something, 1 minus 15 over 100 to the n power, because 1 times n is n. So here's what I'm going to do. I'm going to leave that. 1 minus alpha y equals, and I'm going to do 15 over 100. And it's 17 over 20. You know what? I don't want to do that. I want to put it as a decimal. 17 divided by 20 is 0.85. Now, I want you to think about that. If you remember your laws of exponents and your exponential functions, your growth and decay, if you are depreciating, do you see that? Normally we would say, oh, it's growing 100%. It's growing like by 102% each year, meaning it's getting 2% bigger each year. This is getting 15% smaller each year. So this is that situation where I would take 100 and subtract 15 from it. That's 85. So that means each year it's only getting 85% bigger because it's losing 15% each year. If I were to change that into a decimal, that would be 0.85. And remember those exponential functions, how you did the first term times the rate to the n minus 1 power. This is kind of that same thing. The starting amount times the common ratio, it's decreasing. It's only growing 0.85% each year. But remember earlier when we did that n minus 1 or n, and we realized that, oh, you know what, this needs to account for the 0 where this is 1 and we start at 450. So you could definitely figure it out this way, but if you kind of remember the sequence stuff, that will come into play too. So now let's calculate the value of the washing machine after 4 years. So the future value equals 450 times 0.85. After 4 years, we said it was to the n power. Remember, it was 1 times n, so it's just to the n power. So the future value equals, and I should have put this, but I didn't, 0.85 to the 4th power. If you put that in your calculator, I got this beautiful washing machine is now only worth $234.90. It was euros. Whoops, I'm going to put my little euro sign. Not a very pretty euro sign, but there it is. So, 234.90 euros. Find the value of the washing machine in 100 years. You would expect this washing machine to not be worth very much in 100 years, right? Hopefully your common sense here is like, oh yeah, it shouldn't be worth hardly anything. To the 100th power. When you put that in your calculator, this is what you get. It says 3.94 times E, and then it says -5. You have to remember how you read that. So, remember E just means we've got times 10, right? So this is like 3.94 times 10 to the -5. Okay, so I'm going to move this over 1, 2, 3, 4, 5, put my decimals. So I'm going to fill in the zeros. So the future value after 100 years would be 0.1234. 1, 2, 3, 4, 3, 9, 4. That's euros. And yeah, that's not even worth anything, right? It's really worth $0. Yeah, that's not even a penny. So it's not worth anything. It'll cost you more money to haul it off than it will to actually get rid of it. All right, that concludes page 5.